Okay, at GCSE we learned that speed was equal to distance over time. Now at A-level we know that speed is equal to the change in distance over time, so ds by dt. That means if we differentiate the distance travelled, we get the speed, okay, because it's the change in distance over time. That's what this means with respect to time. Okay, so then by no huge leap, we can say that if we integrate the speed with respect to time, we'll get the distance travelled. Okay, now let's look at this. So we've got a VT graph, and we know that the area under the graph, this bit, is equal to the displacement, okay, equal to s. So we can say that if we integrate the velocity or the speed over this time between here and here, then we will get the distance travelled. Okay, so the area under the graph is us integrating this. Okay, so we've got this curve, right? This is the curve y equals f of x. Then the same thing works. We can say that if we integrate y with respect to x, then we get the area under curve. However, there's one more thing to think about, which is that this is we want this yellow bit here, right? Okay, so we've got to integrate with some limits. That's why we call it definite integration. Okay, and our limits are going to be, we're going to put the bigger number, which in this case is 0, at the top here. And the smaller number, here -2, will go here. So we always have limits here and here. Okay, let's practice a question. So it's given us this curve, it's told us the equation, which is here, and we've got our limits. We want to find it between x equals 1 and x equals 3. Okay, right, so we're integrating. So let's write it in a nicer way. So we've got y equals 3x plus 6x to the -2, because we don't want it written like this, over x squared. That's not good for integration. So then -5. And now we're ready to integrate. Okay, so integrate. So we write what we're going to find. We want to find area. So area equals integral, and we put our limits on. Big one at the top, small one at the bottom. 3x plus 6x to the -2 minus 5 dx. Okay, we need both of these bits to show we're integrating. Right, now this is important because the notation is very specific here. So we have square brackets. This is our next step. Okay, and now we integrate. So we've got the 3 and then put some brackets, x. We add 1 to the power here because this was x to the 1. So now it's going to be x squared, and we'll have a half here, plus 6, and then we do our brackets. Right, adding 1 to -2 will give us -1. And so this is 1 over -1, and then -5x. So this was x to the 0, and now we've got x to the 1. Okay. Right, now, those of you who remember plus c might be wondering why I'm forgetting it here. But because, if you think about it, you'll see in a minute why the plus c's are going to cancel. When we do definite integration, we don't use plus c. If you add it, then it's fine because they'll just cancel out, but we don't need it here. What we do need, however, on the end of our square brackets, we need to put our limits on. So 3 and 1. Okay, so this is the notation. This is step 1, this is step 2. Step 2 will always have square brackets with some numbers at the end. Okay, now let's keep the square brackets and simplify what we've got in the brackets. So this is 3 over 2 x squared plus, okay, this 1 over -1 is -1, so -6 x to the -1 minus 5x, okay, and 3 and 1. Okay, now next bit of new notation, so it goes from square brackets, and now it's going to go to curly brackets as we substitute these numbers in, our limits. Okay, so first let's substitute the 3 in, so we've got 3 over 2 times 3 squared minus 6 times 3 to the -1 minus 5 times 3. Close those curly brackets, and now another set which we're taking away. Okay, so now we're taking away some curly brackets with the 1 substituted in. So 3 over 2, 1 squared, minus 6, 1 to the minus 1, minus 5 times, can I fit it in, times 1. Okay, and then we've got to close our, that's a curly bracket, not a square bracket. Okay, so we've substituted our numbers in. Now let's work out what each of these brackets is equal to. So this one is going to be 27 over 2 minus 6 over 3 minus 15. Okay, minus, it's quite boring, so this minus. Okay, fortunately we're in C2, so we can put this in on our calculator. So, but it is important to show all the steps. So let's work out this bracket first. Okay, so for this first bracket, I got minus 7 over 2, and for the second bracket, I got minus 19 over 2, and then so if I do minus 7 over 2 minus 19 over 2, then I get 6. And now I've found this shaded region here. We've found the area under the curve. Now, if you're interested in the proof of why this works, I'm going to put up some videos with the proof.